both of these things. So you have to start learning the finance as well to understand these things, at least the things that requires to management of a kind of a system where economics is involved, everything. So take some, if you want to go into the detail, take some financial courses of a basic level for accounting and economics, then you will be understand better.
Okay, sir. Now we are live on Facebook and recording is also started.
Just give me a second. I'm just sharing,
Okay.
and then we'll
sure.
start.
Sure.
Sir, can you tell us how can build a logic without Stack Overflow and Google?
You have to ask people who are building the systems before Stack Overflow and Google. They can answer it better. We cannot. None of us can.
Or the creators of internet.
Okay, let's get started. I had to attend a wedding in the last class, therefore was not present because please, Abiha, please mute your mic. Yes, I was saying, let me get started. That in the last class I was not present because I was attending a wedding of a very close relative. Now today, before we get started, Zishan had already and Uwais have already and Anis Bhai have already given you a brief introduction to blockchain. The story about our learning blockchain started about 10 years back, when even blockchain was not present. We had always thought that at some point, both economics, finance, and technology will merge. So therefore, Zishan, you started your financial studies, I think 10 years back?
I know more than in 2006. CMA, with CMA.
Yes, Zishan started his in 2006. And I started my finance and economics and this study in 1982. Basically, we have both of us have a extensive finance and economics background. We are not amateurs in this field and accounting background. So this is the time we were waiting for. Now we have to understand, all of you have to understand something. In the real world we are operating, we need a technology where we can make payments to each other easily. Basically digital money. When everything else is digital, why not money? Of course, the problem with this is that up to now, governments have been using and misusing money as a tool to basically hide their incompetence. What they do is basically when they are in trouble, they print notes. In Bitcoin, there's a limited supply, and everybody has agreed on that. The same goes with Ethereum. So therefore, you cannot increase the supply of money. And this concept and the control is called decentralization. The money, for example, US dollar or Pakistani rupee is a centralized control currency. Ethereum and Bitcoin and others are much more powerful because they are decentralized and they are not controlled by a single individual. That is the first benefit, or in a single government. All of us, the community basically decides of how much money is going to be printed beforehand, not afterhand, when the blockchain starts. So therefore, in the real world, I believe that in the long run, to get us out of this trouble of what politicians have been doing, of creating inflation, is the only way forward. That's the first thing. Yasser, you have raised a hand, please.
Yes, sir. Thank you. So you talked about that Ethereum and Bitcoin. All these coins are limited. So what happens when these coins are not to be mined? I mean, when there is no coin to be mined, all coins are
There's nothing wrong with it.
mined.
The issue is when all the coins are mined in Bitcoin case, you will use a smaller and smaller fraction. And Faisal, you have a question?
Yes, recently in Pakistan, they have almost like make it criminalized to have cryptocurrency trading or something. Feasible option looks here is only NFTs, because all the financial trading like DEX or anything related to having money, they have made it almost illegal. Although there is no law, but in Pakistan they just issue a notification without any parliamentary hearing or something. So is there a chance that industry will push for the recognition of blockchain or for the cryptocurrencies and the whole DFI stack? Is there a chance from Pakistani industry to have some consultation with the government on this?
No, Faisal, you have to understand. When Uber came along, who were they disrupting? The taxi drivers. When crypto came along, who are they disrupting? They are disrupting the government, the status quo. Of course, they are going to do whatever they want. They can do in their power to stop it, but now the cat is out of the bag. Nobody can stop it. For example, in Pakistan, I think yesterday, our currency reserve were $18 billion or $17 billion, if I remember correctly. Last year, people from Pakistan were trading cryptocurrencies, were total was $20 billion. So it's already bigger than the State Bank. I am guessing, of course, and estimating, by end of 2022, end of this year, we will most probably be trading in $40 or $60 billion. So therefore, most of the economy will shift to crypto no matter what they do. And of course, this is going to happen no matter, because it's a global phenomenon. Nobody can stop it. American government will also try to stop it if they won't try to stop it if they are intelligent. But China has already done it. All the authoritarian governments in the world will try to stop it, but nobody can stop it. Yes, Ali.
So I was just raising a point that even if you try to stop, they can't because it's decentralized. So all the efforts they put in, it would just create the greater hype for the technology and currencies, relevant currencies.
It's just like when Christianity came along or Islam came along. The more you try to stop it, the more it will grow. The best way to tackle it, if I was the government, was ignore it. But even then it will grow. Therefore, actually, from our perspective, because we are not traders or investors, in this class, we are focused towards technology. And for example, I'll give you an example. If I want Internet of Things payments, for example, if I want to make a payment, a fridge wants to make a payment to a technician to come and ask it to come and repair it. Blockchain is the best way to do it because there is no central authority. You know exactly if it is, if the transaction is executed, I will be paid and so on. So therefore, I don't have to trust anyone. I trust the system. This is called, I'm talking about in the case of Internet of Things, this is one thing. Now, I've asked all my metaverse students also to take this class. The reason is that the same concepts apply in the metaverse. So in extended reality or in reality, blockchain is going to play a critical part of the economy. An extremely important part. Yes, Ali, you had a question?
Sorry, sir, I just forgot to. Put my
Okay. Amir, you had a question? Amir, I think you have a
Hello,
question. Yes.
sir. When will regularize digital currency in our country?
Who knows? The thing is, we will follow the rest of the world, and as we go along, so therefore we don't have to worry about these things. It is
It is
going to
not
happen.
done in US as well. It is not done in US as well. So I worry about Pakistan.
So therefore, just relax, and the technology will take its own course.
Okay. Thank you, sir.
Okay. Anybody else?
So I have a question. If a developer create an NFT, they required a gas for the transaction to display a product on any meta NFT platform. If they're trying to purchase from the Binance and other exchanges, FIA will trace you and ask a question, what are you doing? What will developer do in this situation right now in Pakistan?
We are not buying or selling anything. We are facilitating others to buy and sell. We are addressing a global marketplace. FIA is a very small thing in a very small region. What we do, software development, we do it on a global scale for international customers.
I'm
Therefore,
basically
what
trying to
happens
ask, if I create an NFT of an image and also float in the main Ethereum, it's my
The thing-
NFT for example, what I can do, sir?
Bilal, we are just getting started. In the first class, you want Zishan to tell you how to create an NFT. Let's first understand the programming language and all the rest of this stuff. Just you're jumping the gun a little bit. We will cover everything. And our way of teaching, my and Zishan way, we have been together for, I think, 20 years. Our way of teaching is we relax and teach. We are not try to hurry things up. So therefore, in due course of time, you will learn everything step by step, in depth. So therefore, I just before I hand it over to Zishan to continue, we have to understand a lot of, I have asked a lot of, this is going to be the economic part of technology. How to exchange value between different participants. It is going to happen in the real world. All of you must have heard, when you worry about Pakistan and others, heard the people saying that first they laugh at you, then they oppose you, and then they join you. It's just a question of time when Pakistan and America or any other country will be issuing digital currencies themselves. It's just like what Facebook was doing. They even in my post, if I mentioned blockchain, they were barring me from making boosting my post. But at the same time, they were working on the cryptocurrencies themselves. The same is happening everywhere in the world. All the state banks are now working to create digital currencies, and those who are not will suffer deeply in the future. Our job is to focus on the technology and leave the politics to the politician. They will do whatever they have been doing for the last 200 years, 2000 years or 20,000 years or whatever, playing games. But eventually, you cannot defeat ideas. Now, Zishan, let's get started. Let's learn Solidity.
Okay, so today I'm going to start from the point where we left in the last class. We had set up the hard hat. We run our application. We deployed the contract on the local host. And what we had to do is we had to deploy the contract to the testnet, so our cycle gets complete, and then we can whatever we wanted to do with the code and everything. So let me first share my screen. So we did the step 0, 0, 0 and 0, 1, and we discussed that we have to create the hard-hat project with TypeScript. For that, I had showed you all the details, all the steps, how you create the repository. So all the installation steps, I'll skip those today, but I'll show you that what we did. Let's say, so this is my folder. I have what it in it is already is. I have already done few commands for npm init. This is already done in this. Npm install -tab hard-hat. These two commands are already been executed. So after that, what you have to do is you have to call npm npx hard-hat, and it will show you few projects type you have to select. So I told you last week that we're using the create advanced TypeScript structure. Once I'll run it, it will create the structure and it will ask you to install something, which we will not be going to do it because I have already created this setup as well. So you have to run this command, and then what setup you will have is this one. So all these steps are already been done and already set up, so that we don't have to waste time on the installations. So this structure has been created with TypeScript and the steps I have shown you here, so that it has everything installed, node modules, TypeScript structure, and everything is already there. You just have to come here and start writing your code, whatever you wanted to do. So in last class, we seen the basic structure of a contract. We saw we have a test, we have a script, we run those contract deployment on the local host. Today we are going to install set up the deploy on testnet. For that, we have to do something setup related to the URL. So I'll remove this guest reporter in Etherscan at this moment because we are not doing it. So I don't want you to confuse. So once you set up your project, you build a contract, everything is done. You have to deploy your contract. For deployment, hard-hat gives us the feature that you property you add in your hard-hat config, name the network. Inside that, you add the network, on which network you wanted to deploy. Either you wanted to do with the Robston, or let's say Rankb, or whatever. So at this moment, I'll wanted to do with the Robston. So what it need is, it need a URL from which it will deploy to the blockchain, and it needs a private key. So for private key, I'll share the link afterwards. I forgot to take that link, but I will not show you how I'll extract this private key from my account. And the structure, when you create this structure, you have this env.example file. Just a moment. It has three properties: Etherscan API, which we will not be using at this moment; Robston URL from
Zishan, could you increase the font a little bit?
Yes.
For Zoom.
Oh, that's too much.
Yeah.
Okay. Okay. So now what we have is the Robston URL. So you have to go to the Alchemy and get this URL. So I'll show you how you can get this URL. And you wanted to have the private key of your account, your Ethereum account. So I forgot to take out the link. So I'll give you that link as well, how you extract the private key from your MetaMask. Okay, so now what we have to do is we have to, this .env.example is example, and it's part of a GitHub. Whenever we do these keys, and all these keys should be in a .env file, which will not be the part of GitHub. So I'll create .env file, and I'll copy all this over in env. I don't need Etherscan. For Robston, I'll show you how we can get this URL, and I'll extract the private key as well. Okay. So assumingly we have both of these properties. So what will happen is the URL will be replaced over here when we compile or try to deploy, and the accounts, for the account it will extract the private key. With private key it will set up your account. So I have an Ethereum account. When I'll try to deploy this with this private key, so from my Ethereum account it will go and deploy to the any testnet. So for now we are talking about the Robson. So what I'll do is, first of all, we need to do two things. We need this URL so we can see eth.robson.alchemy, your alchemy key, and the private key. So first we have to go to alchemy. Alchemy is a service which provides you, which facilitates you for the deployment. So you deploy from the Alchemist server, and they do the they provide you many configurations, like you can see how many requests has been requested on your contracts and all those things. So what I'll do is I'll try to log in. I already have an account. You guys can also create in your account. And from there, what you will do is we have a create app button. Click the create app, name it. Let's say I will say Bootcamp. Bootcamp. Just name it Bootcamp. Environment, at this moment I am in development environment. Which chain I wanted to select will be on Ethereum, and which network on Ethereum. So if you are using Alchemy, some of you, if already using Infura provides you the app, and in that app you have all the URLs, so you don't have to select while creating the app. But in Alchemy you have to select. So I'm selecting the Robson and create app. It will create app with the name Bootcamp. I will click the view details. In here we have view keys. This view key will give you the URL. So what I'll do is I'll copy this and I'll come over here and I'll show you that this is the exact same URL except for your API key. Okay, so you have API key. Now you need the private key. So I'll stop my screen for a little while just to extract the private key from my account. That's the test account eventually, but even then I'm avoiding how I can extract and what my private key will be. So I'll just replace that private key from this file. Okay, so okay, so in .env file, I have Robson URL and private key, both private key of my account. And this is the .env example file. Now all these things are setups for private key. Yes, this is the link. So what you can do is go to your account. In your account, you have a 3 dots. When you click on 3 dots, it will show you the menu. In menu, you click on the account detail, and from there you click export private key. When you click on export private key, it will ask for your password, MetaMask password. From that MetaMask password, copy your private key and then paste it over here. That's it. So you will have your Alchemy account connected to your application, and you have your private account, private key. Once you have both of these things, you are done. Now what we have to do is, at this moment we have a default creator contract. We'll go with this so that we know how to deploy it. So this creator code we already have. We have this deployment script. We'll go with this deployment script as well. We have discussed this in detail in last class. So what I'll do is I'll run npx hard hat compile. Unrecognized. So it's compiling the code, and once it is compiled, you can see the result over here that you will have artifacts folder. In that artifacts folder, you have your ABI and your bytecode over here, which we have also discussed in last week, and you will have the type chain folder. In type chain folder, all your contracts have types, so you can call them individually, as I've showed previously, and I'll show that today as well. I will show today as well. Okay, so the compilation is done. Now what we have to do is we have to deploy it. For deployment, the script is already there. What it does is calls the contract factory and access the greeter, and then it calls the greeter.deploy. Once it is deployed, it will show us the address, and we can check that address on Etherscan. So I'll go to the terminal and I will write npx hard hat run scripts, this folder name, and deploy.ts. Okay, once when I'll call deploy.ts, as I explained in last class, that it will just create a temporary blockchain, deploy it, and finish it up. So it will not be the actual testnet deployment. It will just temporary localhost deployment, which will even not available after this call. So that's the temporary. So in that command, what you have to do is you have to type flag network and say Robson. But if you write Robson, that means you must have this Robson key over here. If you have ringkb over here, then you cannot do it with Robson. You have to do with the ringkb. So at this moment, we have Robson over here. So I'll run the command for the Robson. So npx hard hat script deployment Robson. Now it will access my MetaMask, access my private key of my account, and then try to deploy with that account on Robson Etherscan. On Robson network.
So what about the gas fees and stuff? So we need to, if we need to increase or decrease the gas fee, how we can do with that with the hard
Yeah,
hat ahead?
you have to specify the JSON object while the deployment, but at this moment we are not going into the gas fees problem because we will not face this problem at this moment. So once we'll move forward, I'll show you how you can, even while deploying, you can specify the gas amount with the JSON object. So we'll discuss that at the later point. So you have this contract address, and what you can do is you can verify, go to the terminal Robson etherscan.io and just run it. Okay, so you can see your contract is deployed as we have address 80133. So you can see this is our 80133. It says contract created from, this is my address. This is my Ethereum address. And it is deployed, and you can see transaction ID and everything. At this moment, there is only single transaction. So we don't have anything else at this moment, but our contract is deployed. Now anyone can call this contract if anyone has access to the ABI and the bytecode, they can call our contract and send the transactions on our contract. So that's the cycle over here to deploy our contract. Any questions over here, so we can move forward?
So this Robson.io is showing that your contract is verified already. You have not done it, then how it is possible?
Yeah. Basically, this hardhead project has created a basic contract for us, and world is using it. Literally, world is using it. So anyone must have gone to the Etherscan and verified that code. So your code, if you deploy a contract and it has a exactly similar code and exactly, because this code will generate exactly similar intermediaries, so that's why it is showing you the exactly the code that it is verified. So once anyone just did the verification with the code, and you deploy the same code, it will show you the already verified. That's why it is like this.
So if we had a custom contract, we would have to verify it, and Hardhead doesn't do it automatically.
Yes, definitely. Because that's why there was a property I removed, Etherscan. There was called Etherscan API, and you can see we have this Etherscan API key. So you can verify your contract as well with the Hardhead as a plugin task, which helps you to verify this.
And sir, what are these files in typechain folder?
In typechain folder, basically, that's where the quality of Hardhead is, or the benefit of Hardhead is. It is the actually when you are working with any project, you need to communicate with from the client side to the server. In blockchain, we have a contracts. With contracts, when you wanted to communicate with contracts, you wanted to have access to their interfaces, their functions, what is inside the contract. So generally, when we working with the Web 2.0, we have the API, we call the REST API. REST API goes to the server does the thing and returns us. We don't have the exact detail that if the URL we are calling will be the correct or not. In blockchain, we don't have a single server. We have interfaces. So we know that a contract X with the address ABC will have a function, let's say get greeting or set greeting. For that, we need what we need to do is we need to have ABI for the contract. As I showed you this greeter.json, this is the ABI abstract binary. We have discussed in detail in last class that it has the input, let's say string greeting variable, function greet, which will get nothing but will return the string. Another function which will get the string and update the data. So this is the interface of our contract. With this interface from client side, using Web3 or Ether.js library, you can communicate with the contract. For that, what Hardhead does is Hardhead creates the types. Hardhead creates the TypeScript files, TypeScript classes, and put those ABIs into it, and helps you to just go and call your contracts. So you see, in factory, you have greeter_factory. It has same ABI, and it has functions deploy, attach, connect. I'll show you those functions. And then you have the this is the factory contract which helps you deploy and connect, and this is the actual contract which helps you call, you see, greeter and set greeting. These are the functions inside our contract: greet and set greeting. So they have given you the classes of type, so that from the client side, from any JavaScript application, you can communicate with your contract.
So basically what I understood is that this will be helpful when we are using web3.js to communicate with the client and then backend.
Even in your deployment, everything, let's say this is the deployment script. Let's say I wanted to use, just a moment, let me show. So I just copied everything. If you are pro TypeScript, you will love it. Okay, so So what it is doing is basically when you call ethers.greeting.greeting, it returns the greeters factory class. That's what we have here. Because of that, when you call greeter dot deploy signer, greeter dot attach, all those functions available because of this typing, because of this class. And when you have this variable, this is actual variable for what you call the contract. So now what I can do is here, I don't want to at this moment. Okay, life the attach is another story, so we'll keep this like this. And what I have to do is after deployment, I want to call a function. So what I'll do is greeter dot greet. That's how I'll call the function. I'll say const result equals to await. All the functions you write in your contract inside JavaScript, they will be available as a promise. And then I'll do console.log. Because this is just getter function, it is not a transaction, so you will get the result directly. If it's in a transaction, then there is another story of it. So let's say set greeting. Now when I'll call it, that means, sorry, I'm deploying it again as a new contract and I'm calling the greet function. So otherwise we can use the same contract as well. I'm not going into that as well. So we have this dot attach function. Here we can specify our address and use the existing contract. So I'll explain it later. So once you do this, let's compile. We don't need the compilation, but it just been in my habit to compile every time.
Sir, what's the benefit of Etherscan and Alchemy?
Etherscan, Etherscan is the blockchain explorer. So everything on going on the blockchain, Etherscan provides you the view to that world, that how you can, what contracts are available, what functions are available, how you can access your contracts, addresses, and everything. So Etherscan is your access to that blockchain. Okay, so we have this.
So, sir, blockchain explorer for Etherscan is maintained by Ethereum Foundation. I see.
Just a moment. I just run the wrong script. I had to run set greetings. Yeah, can you repeat your question?
Sir, I said that I was asking that the blockchain explorer sites are maintained by the respective foundation. So like Etherscan is maintained by Ethereum Foundation or for what?
Basically, it's maintained by the community. So it's not that. Why there is a problem?
So I think you have to compile it first.
No, I just
You're missing the format.
When you don't focus on the name, then this happens. So now the script is right. It's trying to deploy it. And what it will do is, so now what you need to understand, this script is actually a JavaScript file, and you are communicating with your contract using the JavaScript. So now if it's a React or it's an Angular or it's any JavaScript application talking to the contract, this will be the style you will communicate with your contracts or your blockchain application. So it's deployed. So once it is deployed, it calls this greeter.greet function, and you have the result hello hardhat, which is which we have set on the compilation, on the deployment. So we have called the hello hardhead, which is went into the constructor hello hardhead, and this is done. Okay, so now what the last thing, let me show you that when our contract is already deployed and I wanted to use that contract and run a function. So what I'll do is actually the name is incorrect for the file, but now we just have to go with it. Set greeting 1, and what I'll do is I'll not call this as a deploy. I wanted to use existing contracts. This is my existing contract, so I'll pick this up. Let me show you this on Etherscan as well. So that's our contract. We have only one transaction. You see, this is the only one transaction. Now what I'll do is I'll call the greeter.attach and I'll provide this address. Now we don't have to call the deploy event. We don't want to, let's print the address. But we don't need it because we already have this address over here. Now I have to call the function, which is actually a transaction. So what I have to do is I have to call greeter.setGreeting, and then I'll call the new greetings. Once you call this, this is a transaction. So it will, at this moment, this contract does not have anything returned. So this contract does not return anything. So we don't have to worry about, but it will return us a transaction, txt, which is type of contract transaction. Generally, you don't need it. You can ignore it. But if you are pro TypeScript, you will enjoy working with like this contract transaction. And you have this transaction. What it will give you, it will give you the detail of a transaction. So I'm printing this over here so you know the detail of the transaction as well. And once it is done, we can see the results. So what we are doing, we are using existing contract. Okay, let's move to the script. I'm not compiling it again, and I'll go to this.
Sir, when we can do it this way, like we can call contract this way, then why there is need for web3.js and ether.js?
We are using it.
Libraries?
It is ether.js which is helping us.
So it is ether.js.
Yes,
sir.
it is
Thank you.
ether.js. Okay, so you see, we have a transaction object, and that transaction object has a hash, and all these details. There are a lot of details which all we don't have need at this moment. I'll let me refresh this interface. Transaction is not reflected yet. It will in a while. So what I can do is I can copy this transaction hash and paste over here, and it will show me the status of transaction. Transaction is not reflected.
I think the transaction is still in process.
It should not.
Sir,
At least if I have hash, then I can see this detail. It at least the
yes, sir. It always take time to show up on.
Yeah, but
not
transaction should not. Okay, let's see. Wait for a while, and we'll see. Meanwhile, I have also executed another transaction.
We can only compile when we change in our source file. Am I right, sir?
Yes, yes. In our contracts.
Sir, when we deploy a contract on any test network, which is basically this create a block.
Sorry, can you repeat again?
Sir, when we are try deploy the contract on Robson and other test network, basically they creates a block, new block.
No, 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 no. It is a transaction. A block is created every 15 second, and many of the transactions will be part of this.
Sir, I believe the contract address which we used is not the right one.
Okay.
You actually deployed the deployed the contract again when you mistakenly run the command, and I think the contract address changed at that time.
No, you see, that's the deployed contract. And let me just check, run it again and wait for the transaction to complete txt dot wait.
So going forwards, is Web3 a recommended platform to learn, or should we focus more on Ether.js?
I believe that's maybe will be decided in future. We don't know literally yet,
Right.
but both are trying to do something, and Ether has come a quite long ahead, and it is connected with Hardhead, and everybody is using now Hardhead with Ether.js.
Okay, thanks.
So what I'm doing is, when you run a transaction, it executes the transaction, but if you wanted to wait till transaction is completed, then what you can do is you can call the transaction.wait. So it will wait until the transaction is actually completed and executed on the blockchain.
So sir,
you
the
see,
transaction
we
has
have,
generated.
you see, we have this result, and it is waiting for the transaction to be executed. But the thing which I am not able to understand is it should at least show us the transaction on Ether scan, that's what your transaction is.
So what you mean is that transaction has it generated after the transaction has happened, or is it generated when the blockchain receives the transaction request?
When transaction is completed, that means transaction has been executed on the blockchain and accepted.
So hash generates at the end or at the start?
At the start. Okay,
Did
so
the
it's
contract
waiting
has
that
a
okay, just a moment. So it is waiting, that means because these are the test servers, so it is taking time, and I was in a hurry, so trying to do it again and again. So we'll move forward. Meanwhile, transactions will be executed and we'll have some results. So I'll show you these that things has been displayed over here. So let it be running, and we'll move forward and see what we wanted to do next. Then I'll show you once it is done. Okay, so that's it. We have done the deployment. We have seen how we can deploy the contract, and how we can access this contract after the deployment. This is the basic steps, and now actually we'll be moving to actually using the Solidity and contract and everything. Any questions here, so I can move forward?
Yes, sir. What's the benefit of alchemy, and is it the standard way of calling
Deploying?
No, sir. Calling the deployed contract in the. You have pasted the key over there and compiled.
Basically, The Alchemy, you see, we have what we did is Alchemy has given us an interface, a nice interface. Whenever you use Alchemy to deploy your contract, it will give you all the response requests coming to your contract, how many requests were successful, what was the response time, and all these details will be provided by the Alchemy. There is another service called Infura that also provides such same thing, but now Alchemy is being used more, and they are projecting it more. So definitely when new things come in, you might wanted to try. So Alchemy is doing this. Now what you have to do is, if you go to Etherscan, maybe we have this or not. For deployment, you have to do manual steps to copy ABI and then deploy on your blockchain somehow manually. All those steps has been removed by Hardhead, and you just have to call these URL, set up everything, and then call the deploy, and it will deploy directly on your blockchain, and you don't have to worry about the nitty-gritties of how you will be copy ABI and everything. So that's why Alchemy and Infura helps us. And to attach the contract, definitely when you wanted to access your contract, so one of the best option is that you for existing contract, you call greeter.attach, so it will attach existing contract from the blockchain. So the transaction is still in progress. That means the servers is the option, because it is a test net, so it is taking time. Okay, let's just move to the next steps.
Sir, I have one question. When
Yes.
I'm using the Web3 in React, they send me a compile time error, polyfill, and some like resolver dot fallback.
Sorry, can you repeat again?
When I'm using Web3 in React application, they send me a compile time error, like polyfill and resolver dot fallback. They are like that.
That it must be your configuration, your node modules installation, all these things, and this is very specific to your situation. I cannot give the general answer, but mostly it is because your node module is not properly set up. You are not accessing the right Web3.js, so that's why it is causing the problem.
Okay, thank you.
Sir, I have one question.
Yes.
My question is like when we will deploy the contract on the Ethereum blockchain, okay, does the new block will be created, or, and my second question is like, suppose if I do the 10 transactions on the Ethereum blockchain, does the 10 different blocks will be created, or there is some different scenario?
No. Whenever you do a transaction, even you deploy a contract, you transfer Ethereum, you run a set greeting function, or any action you do on with your with blockchain application, you are generating a transaction. Deployment of contract is a transaction, sending in Ethereum is a transaction, calling a function is a transaction if it's changing the state of a blockchain. So all these things are transactions. So when you run a transaction, transactions go to all the nodes. So let's say there are 1,000 nodes in Ethereum blockchain, so your transaction will go to all those nodes. All those nodes will verify your transaction and keep your transaction in the transaction pool. Once 15 seconds completed, after every 15 seconds, what node does is, on each computer, on all those 1,000 nodes, it picks the transaction from the transaction pool, create a block, try to solve the puzzle. So all those 1,000 nodes create block, which should be the same block, and transaction can be different, but we are not going into the details. So pick up the transaction, create the block, and try to solve the puzzle. Whoever wins the puzzle able to add the block into the blockchain. Then it's, so in single blockchain there can be 10 transactions, there can be 20 transactions, there can be 30 transactions. In Ethereum, the limit of a block is based on gas consumed, and I'm forgetting the total amount of gas allowed in a particular block. So we can verify, we can find out on the internet. That's not a big thing. So that's how the block is created, and there can be many transactions inside a block. So your one transaction does not create a block.
Yeah, I got it, sir. Thanks for.
Sir, so for example, if we write a contract for Ethereum blockchain, do we have to write another contract for another blockchain, or the same contract can have, same functionality on the different blockchain?
Other blocks, what other blockchain means?
I mean, the blockchain which Bitcoin is using.
We cannot do for the Bitcoin, but we can do for the Polygon and everything. That's the different story. You can write the blockchain which is supporting EVM, Ethereum virtual machine, can be done. The code you write with Solidity will work on all those blockchains which has EVM, but you have to deploy separately. But Bitcoin is not Ethereum. So all those Ethereum blockchains, so when you call Ethereum blockchain, you say that the blockchain which supports EVM, Ethereum virtual machine. So those blockchains can you can deploy the same Solidity code, but you have to deploy it again. So you will be deploying on Ethereum, you will be deploying, let's say, on Polygon, and you will there will be two contracts. But let's say if you are using the Solana, then it's completely different story. You have to write the Rust and everything, and so that's a completely different thing. That's how it's being done.
Thank you.
So I have a question.
Yes, please.
In a multi-developer environment where there are multiple developers, let's say Solidity developers, like so in a perfect world, what you showed right now was you created a smart contract and you deployed it, let's say, on the Robster network. But if you have multiple developers working on the same smart contract, how does that play out? Are they deploying it on the Robston, or is there a local blockchain like Ganache? Or Ganache is purely desktop related, but how does that, like, share some experience? Like, how does a
Actually, I have explained it in our first class. So what we did is, let me show it again just for the reference. What you can do is go to your folder and call npx hard hat node. It will start the local blockchain.
Right.
And oh, it is taking time. Yes. It has given you the 20 accounts. Each account has 10,000 Ethereum. And now what you can do is, this terminal is already in use. So I'll open another terminal. And I'll say npx hard hat run script / deploy.ts test network localhost. So what it will do is it will deploy on this localhost. So let me run that.
Scripts.
This is the blockchain running in, and you will start seeing
surprising that it's taking so much time on localhost, even though it doesn't have to do any specific validation.
no, basically the terminal, because of this process, the terminal is some. Let me close it. We don't want to wait. It will.
And so even on testnet, it doesn't take eternity like it did with last transaction.
Network connection timeout, even on the local host. Why it should be the. Sorry, you were saying something?
I said there must be some problem with the bytecode or something, that it doesn't take so much time even on the testnet.
Yeah, it should not take, definitely. No, it's not the problem with the bytecode. We have already deployed it. I was just trying to run the set, what you call, maybe. Let's see why
Function.
it is.
Set greetings.
No, basically this deploy.ts, it's the simple which were used for the deploy. So that's not the big problem. This is the one. So we
So
don't have
you
to
can
worry
run
about
the function directly from the blockchain explorer.
local host. Why this local host? We already have this local host. There's some other problem because it should not be the npx hardware to script deploy network local host. Okay, just a moment. Okay, so we have this
You
test
should try
mesh.
restarting the node.
I have done, just did it. That's interesting. Yes, now it is done. You see? So that's our local host, and you see the transactions going in our block. So it's like a command prompt or terminal when you run a get or any other node of a blockchain or at your own. So you see this setup, and this transaction, this greeter is deployed on our local host, and we can do all those other scripts like set greetings and all those.
Okay.
Right. So that's how you run it on localhost. Secondly, you do run the test, which I didn't reach it yet, which I had to do. So you can run the test as well to test everything. So then you don't have to even run the local node, and test will work directly.
Okay. All right. Thank
okay.
You.
So let's move to the step 02. Simple storage, it's already been, we have already discussed that. Call the update data, which the set grading, which we have already seen. So we don't have, which we have already seen it. So we don't have to worry about this step. This set greeting. So we have already tested it. So it's updating the data and then trying to read the data. And sir, should I go for the test or move to the 03 steps for the solidity?
I think we should move forward.
Move forward. Okay. Okay. So step 03, for step 03, let's.
Sir, what the second step is simple storage. Can you little bit explain more? What is a simple storage?
It's just the name. It's just trying to show you that when you call the set function, update function, it will update the state of a contract, and then you can call that information later on, which we have already done in set greeting. So when you call the set greeting, it's just updating the state of a contract, and then you can call it. So it's exactly same, it's just a name, nothing else. Okay, so for step 3, what we have is we have few links Satya has attached over here. One of them is, there are few videos and the tutorial in YouTube. What we'll do is we'll follow this link, the first one. We'll follow this solidity tutorial. What it does is it gives you the step-by-step for each functionality, how the basic syntax, comments, types, and everything. We'll follow these steps to see how you need to do, how you will be writing the solidity code, and what are the functions and attributes and the keywords and the fundamentals of language of solidity. That's what we need to do. So environment setup, basic syntax, these are all things we have already done. First application. So you see the very first application, which we have also seen. Let's say we have this code. It's a solidity test. It is a constructor. get result function. So let me start with this example. So the project I have already set up, we'll use this project, and what I'll do is I'll create
A quick question, sir. We can generate as much contracts as we want, and we just need to change the name in the deploying script.
Yes.
And
Yes.
we are good
Yes.
to go.
Yes. Okay, so I'm not using 0.5. I'm going with the 0.8. And if I'll copy complete code, what it will do is it will, first of all, it will give me the warning related to the public, because now with constructor you cannot write the public because it's already a public. And for constructor pure, we'll discuss pure and pure later on. So now we have what we have a get result function, so we don't have to function will go in detail what type of functions are at this moment. What we need to see is a variable called uint with just a basic example, and we'll have another variable uint b. Like any basic programming language, what we have to do is we have to start with the fundamentals. So what in fundamentals, what we have data types, how we'll be using those data types, the conditions, loops, and all those things. So we are to the point that now we need to step by step understand what these things are and how you will be using them. So let's say I have a function and I wanted to do some calculations on inside my function. So what I have to do is I have to create a variable. So if you are coming from this JavaScript background, you will be facing difficulty while typing this data types, because you will be habitual of writing let a, or you'll be habitual of var a. But in typed language, you have to specify type first, then you have to specify the variable name, and then you have to specify the value and semicolon. So that's the first expression. Second expression is another variable, and now we are what we are doing arithmetic operation. We are doing the sum, and then we are returning the result. So that's the simple code. And if I'll run the it will compile this code as well, and you will see this updated. You see, we have another contract. And
So the compile function compiles all the contracts in the contracts folder, or
yes, it's compile all the contracts.
Sir, solidity contracts are like classes, because there is also a constructor.
Yes. They are classes. In this contract, we don't have a constructor that is taking any input, so we will not pass anything. Okay, so now we have this deployment script ready. I'll copy this name. We have already compiled it, and I'll run it on the local host. So our local blockchain is already running, so we don't have to worry about this. And what I'll do is okay, so we have to use the function, not just the the name get result. You see this contract is deployed. What I have to do is okay. So now what we have is we have get result function which is returning something, and okay, so you see we got the deployment and we got the result. The numbers in blockchain, because we have a big numbers which goes beyond the possibility of number stores in JavaScript number type. So they have created ethers.js created the JavaScript class big number. What you have to do is you just have to call the toString. So you will have your result. Okay, so you can see we have the result 3. That's our basic example. Let's move to the second one. Comment, there is nothing special. If you have used any programming language, double slash will comment the single line, slash static open and closing will close. You will have a multi-line comments. So that's the simple in JavaScript, TypeScript, Solidity as well. Variable types. Now, what data types you have is Boolean and integer and string, definitely because of the you have to use these. So in string, Boolean and integers. In integer you have unsigned integer and signed integer with multiple options. So what you can do is you can create int 8, int 16, int 24, int 32, and there are multiple. Fixed point, until this point in Solidity, you cannot create variable with decimal points. So you cannot do 2.5. You do not have this facility to write 2.5. You do not have this facility to write 2.2.5, 2.225. You just have to do the 2, 5, 10. So you have the whole numbers, but not the continuous numbers. Okay, so they are working on it. They have the types, but they are not implemented. If you try to run it, it will not work. For data types, we have seen uint. When you write uint, that means by default you are writing uint 256. That's the maximum size of a variable data type of integer. But what you can do is you can type data type like uint 8. See, but what you will have to understand is uint is 8-bit data type, 1 byte. That means it can store, it's an unsigned. That means you can store from 0 to 255. So if I'll try to store 200, it will work. If I'll try to store 255, it will work. If I'll try to store 260, it should not work. It should give me the error. Yes. So it's saying that it's out of the limit. So you have uint 8, uint 16, uint 24, and goes to the 256, 16. And this goes like this, 24, 32, and list goes on with 8 incremental bytes. Why this so many of data types with single type of integer? Because in Solidity everything costs you. every transaction, every expression, if you store something in blockchain, it costs you in transaction fee. So if you store the higher data type, it will cost you higher in expressions and calculations and everything. So you have to vigilant about what data types you wanted to use and how you wanted to use. If you wanted to use the positive numbers only, do not use integer, use uint. If you wanted to use the negative number, then you use the integer data types. Don't use the uint, because you will not be able to store
So,
that
sir, are
value.
there any optimization checker softwares or something that just analyzes the working of a solitary contract and we can find the loopholes and fix them? Or it's just that we have to judge them ourselves?
Basically, loophole is the quite open-ended question. It's depends on the code. So none of the automated code or software can identify that this is actually a loophole or not. If you are asking user to input a number and you are running a while code with that number and you are not decreasing the value, so eventually your transaction will get failed and you will see the error guess out of guess error. So everything in the beauty of blockchain is, even in the case of Ethereum, that everything costs you transaction fee. So it costs you gas. So if you are running a code which is costing too much, you have eventually out of your accounts Ethereum value, and that's the only cost. It might be the bigger one, but that's the only cost it will be. The system will your transaction will fail and system will not be will be in any trouble. Okay, so
Sir,
that's how you
the local variables are also costing us the variables we use in function.
these are the expressions. These total expressions will go into the cost of a function call. So the function call needs all these expression will be the cost of this function call. So you will have the cost of function call, which includes all these.
So, sir, any variable declaration inside a function would be a memory declaration, and outside the function, it would be storage.
Yes, outside the function, it will be storage. It's part of your contract states. So it is stored inside the blockchain. These variable will go destroyed after the function call is done.
Zishan bhai,
Yes.
You said every transaction has a cost, or every function has a cost?
Every transaction.
Every transaction. Okay.
You ask really technical question, every function or a transaction, because every call of a function out from somewhere, it will be the transaction. But if a function does not change state of a contract, then it's not a transaction.
So
okay,
the memory variable also cost us.
Every expression which is running has a cost.
So it is that memory variable just costs a bit less than the storage variable.
Yes. Okay, so these are the data types, and you will get used to these variables while you will be using the application, the Solidity. So at the basic level, you have Boolean type, unsigned and signed integers. With integers, you have multiple, and you have a string, so that you can store the string data by floating points. You don't have the floating points. Okay. Yes,
Sir, I have a question. Sir,
Yes.
I have a question. Yes. So basically, we have one function, and this function right now is not changing the state of the contract, so it will not be treated as a transaction. Does I'm right?
Yes.
Okay, fine. Yeah. Thanks for confirmation.
Okay, so in variable, we have a different type of storage locations. As we have already discussed, that if you store the variable at the contract level, so it is the state level variable. That means this actual value of this variable will be stored into the blockchain, and you can change the state and everything later on. Local variable, which we have just seen, does not change the state of the contract. And we have few global variables. So we have already seen state variable in case of greetings. The string variable was part of the blockchain, and we can change that variable later on, access that variable later on. So that's the state variable. These are the local variables that does not change the state of the contract or the blockchain. And we have a global variables which we have not seen up till now, which are like this. So these are few global variables which gives you the access of a particular block your transaction running in, the caller of your function, few details like block hash, the hash code of your block, the current block which is executing the transaction, block.coinbase, the miner, the one node which is executing this transaction, the address, this will show that address. Block, the difficulty level, it is again the same, the puzzle you are solving. So every puzzle has a difficulty level, every blockchain has. So that's written the difficulty level, gas limit, block number, the current block number. Your transaction is being executed in timestamp, the current timestamp. This timestamp is the timestamp of a block being created. So in Solidity, you cannot have the dead dot now. So it does not change every second. Whenever you wanted to access the current timestamp, it will be the timestamp of the block creation. It will not be the any other timestamp. So you cannot in JavaScript and any other language we can call every now and then date dot new date, and it will give us the time in even in seconds. It will not be the same. It will be the timestamp of a block creation. Okay, so the guest left message.data, the data is being sent to the function. Message.sender, the one who calls the function. Signature, message.value, the value if you send the Ethereum now is this exactly same. Transaction.origin, the initial caller of the transaction. So I'll show you the few ones.
Sir, in the transaction that you removed, there will no gas fees because there was no changing in state.
Yes. Okay, so what we are trying to do now is actually we'll try to access the timestamp. Let's say access the block number. Okay, so you in 256. So you have the reserved keyword block dot number. So you have the block number. It was the block number maybe. Okay, so so the test is already there. We'll just when you run a script, it actually compile the contract as well. And now you can see this is the block number 5. So because it's running on the local system, so in this local system, I have at this moment I have only 5 blocks. So that's why it is showing me the 5 blocks. And when you're running on the local host, they create blocks for each transaction just for because it's on the local host. You see the block number is 6. Now the another global variable we can verify is unit.
So, sir, the block variable which we are using can only return the last 256 blocks, which were specified in the
Yes.
tutorial
Yes.
point. So, if we have
Yes.
to get the blocks before that, we would use Etherscan API.
Basically, while running the contract, you wouldn't be needing. So they are trying to discourage you to go to that much back into the history of a blockchain. You might have to trying to do something which is not allowed, because why you wanted to go behind the 255 contracts, 255 blocks.
Right. So if we mostly just need to get data from the smart
Yeah.
contracts and we can use interfaces.
Yes. You generally need to go to few blocks of move back or forth. That's it. So you see, this is the timestamp of a blockchain. So this is how you will get all the details. Let me just one more message.sender. So the message.sender is an address. So let me change the data type of this return, and I'll send this. Inside here, I don't have to do the, maybe I don't need to do this. Let's see. Okay, so you see, this is the address of the one who calls the transaction, who calls this function. So whoever they call this function, you can access that person's Ethereum address in the message.sender. And that's how all other properties are also work. Transaction.origin. What happened is when you call a function inside another function, so there is a trail of functions, which if a contract calls another contract, then the message.sender will be the contract. You wanted to access the person who initiate the transaction, then you will call the transaction.origin. So at this moment, we don't have this case. Once we will have this, I'll show you guys that how when you go into these multiple layer of contracts, then you can access the transaction.origin. Okay, so these are the global variables which you can access. So we have state variables which will be stored into the contract, local variables which will be inside the function and they will destroy. The global variables which is available in all the contracts all the time. So you can access some global information from the contracts. Okay, now variable scope.
Ishan, let's continue in the next class.
Okay.
I think you must be. I know you will not be tired, but you
okay,
can
so
teach for a few hours, but the students get tired.
Okay, so we are good till this point. So what we did today is we tried to deploy the contracts on the testnet. We used Alchemy. We saw the Etherscan, how it is being done. We did this. I'll share it in so we can use in our repository as well. So you can see how you can access your private key, and then what you can do is you can run your complete application. So from deployment to the accessing the contract and all those things we have seen, we see how we'll be using the TypeScript for the deployment and accessing the contract. And then we saw these steps, and from the next class, we'll continue from here. So we'll see how these fundamentals will work.
Sir, I have one suggestion.
Yes.
If we complete whole the chapter of variable, I think variable scope is remaining.
This chapter.
Ji.
So he's saying that we should complete the variables in this class and continue from the next chapter in the next class.
Next class, repeat.
Variable is variables are already done. Now we there is a private and public and the access modifier. So we have to learn this detail. So we can do this in next class, and we'll start from there. And that's not a problem for this.
Okay.
Sir, can you also give us some homework for the next class so we can explore more?
Everything we discussed today is your homework. If you cannot set up after today, if you cannot deploy your contract on the test net, then you have wasted your time. So that's your homework to reach to this point what we have discussed in today's class.
Okay, sir. Thank you.
And Zishan, please feel free to commit any changes you want in the repository.
Sure.
Okay.
So fun fact, so we started with 170 students and right now we have 40. So yeah. And we have only one.
We start with the 6 students when the bootcamp will start.
Yeah,
Yes,
but
students
the
get
first class I
tired.
attended, they were about 170 students and now we have 37.
You don't have to worry about the student. That's not the issue of the class. The important is if we can see the 37 participants, excluding me, Sarjan, and Ovesh, it is just focus. If 3 or 4 are trying to learn this, that's good enough for us. What am I right, sir?
Yes. And the second thing is, the problem with recorded classes is that most of the students think, which is never going to happen, that I'm going to watch it tomorrow because it is recorded and we will be available.
Yes.
Yes, in live classes, we have advantage that we can just ask the question
Ask
and
the
we have
question
a
to
very
teacher.
fruitful.
Therefore,
we have a very fruitful.
We have done is
conversation also.
we have a live class as well as a recorded class. Therefore, both will be satisfied.
Sir, data structure in Solidity like the C++ in defining every single data type. Sir, is a pointer concept in Solidity or not?
Pointer, Solidity does not have a pointer concept, but
Thanks a lot,
everything it's everything's coming from the parent language of C and C++. So behind the scene there are these things, but you don't have access.
So basically, sir, because it's a decentralized storage, even if they gave us the pointer functionality, it would be a lot mess up than the C and C sharp.
Yeah. Definitely.
Sir,
Okay,
alright,
thank you, everyone.
Yes.
Zishan, would you please close the recording in Facebook and let's see these guys in next week.
Just a moment.
Thank you so much.
How
can you please, sir, upload these recorded videos on YouTube as well?
Yes, they all of them are being recorded and uploaded.